Okay, question number 10 is a vectors question. We've got a triangle OAB. It says C is the point on OC such that it is equal to 2 lots of O to A. So C will be here. It says M is the midpoint of A to B. So there-ish. It says the straight line through C to M cuts OB at N. So N is here. O to A is A. O to B is B. Find C to M in terms of A and B. So we know that this line carries on and goes through C, and that is also called A. We know that A to B, to get from A to B, I can go back along OA and then plus O to B. So that's going to be negative A plus B. We know that A to M is half of that because M is the midpoint of AB. So to get from C to M, I can go via C to A and then add on A to M. So C to M is going to be C to A, add A to M. We already know A to M, we've just written that down here. So C to M is going to be minus A, because I'm going back along here again, plus A to M. So minus another half of A plus a half B. So C to M therefore is negative 1.5 A plus a half B. Okay, so in part B, we've just shown that C to M is this. C to N is going to be some multiple of that. So C to N is some multiple, so let's say lambda lots, of minus 3 over 2A plus a half of B. We can then say that if we want to go from O to N is 2A plus, so is O to C plus C to N, which is 2A plus lambda lots of minus 3 over 2A plus a half of B, which if we expand the brackets, we have 2A minus 3 over 2 lambda A plus a half lambda B. We've got A in two places here, so we can say then that O to N is lambda times 2A, is A times 2 minus 3 over 2 lambda plus a half of lambda B. So that's what they were after for part 2. We're just saying that we've stated that, I didn't state it, let's say that C to N is some multiple of C to M. We don't know what this multiple is. It might be 1.5 times of it, it might be twice it, just some multiple. So for part C, it wants us to prove that O to N to B is the ratio 2 to 1. In other words, that this part of the line, O to n, is 2/3 of the full part of the line. So in other words, that O to n is 2/3 of O to b. That's what we're trying to prove. So I'm going to say that O to n is some fraction, is alpha lots of O to b. And I don't know what fraction of the line it is. We've already said in part 2 that O to n is 2 minus 3/2 lambda lots of A plus a half lambda lots of B. But we also know that it is some fraction of the line O to B. And O to B is vector B. So it's some fraction of vector B. So these have to be equal to each other. So 2 minus 3/2 lambda A, add a half lambda B, must equal alpha B. Now we've got two unknowns here. We've got alpha and we've got lambda. But what we can say is that 2 minus 3/2 lambda has to equal 0 because there's no A in the other version of O to B, which means we know that if we solve that equation, that lambda is the fraction 4/3, and we can then substitute that into here and say that a half lambda has to equal alpha, so a half of 4/3 is equal to alpha, so alpha is equal to 2/3. And if alpha is equal to 2/3, then the ratio that O to n is 2/3 of O to b. So that means the ratio O to n to b is 2 to 1, which is what we were looking for. If it's 2/3 and 1/3, that's 2 to 1.